our first math question that we have here is pretty easy. They gave us 3 cells, and each of the 3 cells have the surface areas already calculated, and they already have the volumes calculated. They want you to determine the surface area to volume ratio of the cell that would be the most efficient at diffusion. So I said the answer right here is 10, but like you might be able to calculate a surface area to volume ratio, but you might not be able to use that value to figure out which one's the most efficient. So you're always going to take surface area and you're going to divide by volume to find that ratio. That's not going to be on your equation sheet. But you guys can use graphing calculators if you want. So it's a choice that you get to make. No. Nope. So like things like this, or like things like R max. Like I always forget that R max is burst minus dust divided by n. Like that's not on the equation sheet. This is not on the equation sheet. This isn't on the equation sheet.
So going back to the problem we did in class, when we have the burst minus dust divided by n, the n down there is the initial n, right? And the n in the other one is the n at the population. Like you know how we did 1 year and then we did second year?
Yeah. So the R max value isn't going to change after that initial population.
Please, Kendall Hamill. Come down to door 5. Kendall Hamill. Hamlet. Door 5, please.
Okay. So knowing that, all we need to do for all of these questions is to take the surface area, divide by the volume. So 60 divided by 12 gives us 5. 50 divided by 5 gives us 10. And 20 divided by 5 gives us 4. The problem that I foresee is not that you guys don't know how to do the math, but interpreting which one is the most efficient. So efficiency at diffusion means that you need a lot of membrane that will assist things coming in or out of the cell. So cell 2 has the most membrane compared to their volume, so this would be the most efficient at diffusion. Other things that it might say, like which one is the most efficient at removal of waste, or which one is the most efficient at obtaining nutrients. It all means which one's the best at diffusion. So just knowing that you want a high surface area to volume ratio for an efficient cell. Small cells are more efficient because they have a higher surface area to volume ratio. So that's a good thing. Small cells have large surface area to volume ratios. Yeah, smaller cells are always going to be more efficient than a larger cell.
So bigger surface area to volume equals what? Is that what you're saying?
The most efficient cells are small, and they're efficient because they have a lot of surface area compared to their volume if you're a small cell. So if we look, you want a high surface area to volume ratio. You want a lot of surface area compared to your volume. Okay, so if we look, if you're a math person, do you see here that the volume of the sphere and the surface area of the sphere both have the radius in them? So this is radius cubed and this is radius squared. So that means as cells get bigger, their volume increases at a much faster rate than their surface area does. And when there's a lot of volume inside of something, it's not going to diffuse as easily. Like, think of traffic in Joliet compared to traffic in Chicago. Traffic in Joliet is much better than traffic in Chicago. And it's not because we're organized better, it's just we're a smaller city. So things can move in and out of Joliet easier than they can move in and out of Chicago. All right. The next one did not go over very well, but this one's talking about okay, so this one's talking about the axon of a neuron, and it's similar to a cylinder. Because it gives you a cylinder, you know that you're not going to be able to use the same equations that you can for a sphere. So they're either going to give you the equations, or there is information for cylinders for columns. Like they would say that it's similar to a column on there. So sometimes they'll talk about squares, sometimes they'll talk about columns or circles. So they want you to calculate the surface area to volume ratio of the axon as a cylinder with a radius of 0.5 microns and a height of 0.5 microns. So we know that we're going to have to take surface area and divide by volume. So you would just have to, surface area would be 2 pi 0.5 squared plus 2 pi 0.5 times 0.5. And then we would divide by our volume, which would be pi . I canceled out the pi's. I don't want to deal with that. And after I canceled out the pi's, my answer that I got this from like Alberto this afternoon. I got the answer of 8. I think that you're probably right that you don't that you should probably put them both in to be closer to the actual value of 8.05.
So you can cancel them out because like the addition, like you like switch it into 2 separate fractions, you know? No? You don't know? So like it would be 2 pi that over that plus that, and then just put it together.
So it'll cancel out, Peyton? Okay. I trust your math skills more than I trust. Yeah, we just started it. Just started it. Main thing that we did is just that some people forget when we do a surface area to volume ratio, it just means that you take the surface area, divide by volume. And then the other thing that is confusing is that we know that small cells are the most efficient, but small cells have a large surface area to volume ratio. So that sometimes is an easy mistake that students make. Okay, so we still have one more surface area to volume question. All right, so for this one we have 3 cells. Each of those cells, they give you the radius. The one thing that I want you to watch out for is that sometimes they might give you diameter of some cells and you have to figure out the radius. So make sure that you're using radius and not diameter in case they would give you something that was a diameter. But what they want you to do is they want to find how many times larger is the volume of cell 2 than the volume of cell 3. You're not going to have an equation on your equation sheet to say like how many times larger is this compared to that. But I kind of try to just how it works in my brain. I think like how many times larger is 8 compared to 4? Well, 8 divided by 4 is 2. It's twice as large. So I think about numbers that make sense to me, and then I can kind of figure out how I would do that. So I would take the volume, and we want to know how much larger is the volume of cell 2 compared to cell 3. I want to take the volume of cell 2 and divide it by the volume of cell 3. And that's how we would figure out how many times larger the volume would be. Cell 2. I'm not going to put the pi's in because they would cancel out anyway. I set my equation up like that, and a 1,000 times larger volume. Are we good on surface area to volume ratios? We're just calculating those out now. Any more questions on those?